Hello and welcome to my channel. For this session, I will be explaining vectors. First, I will define a vector and make a comparison between vector quantity and scalar quantity and give few examples. Second, I will work on vector operations such as vector addition and how to graphically add vectors and what method to use. And lastly, I will work on a problem application using the vector addition concept with other mathematical concept to solve this problem. So what is a vector? A vector is a quantity that defines both magnitude and direction. For example, suppose that there is this table, and on this table there is a cup of coffee located at point A. And suppose that this cup of coffee was displaced from point A to another point on this table, point B. And the displacement was 4 feet with a direction or angle of 30 degrees. And that's north, that's east. So this displacement with magnitude and direction define a vector which is denoted by 2 letters with an arrow on the top. Define a vector with a magnitude of 4 feet and direction of 30-degree angle northeast. So that's one example of a vector quantity. Another example would be, so this example is a displacement. Another example would be velocity. That's another example of vector quantity. Force, that's also an example of vector quantity. And so these are some examples of vector quantity. On the other hand, to make a comparison between vector quantity and scalar quantity, a scalar quantity only define a magnitude, so it doesn't have any direction. So for example, speed would be a good example of scalar quantity. Elevation, link. So all of these are good examples of scalar quantity. Mass, temperature, and so on. So that's like a summary of a comparison between vector quantity and scalar quantity. Now, how can we graphically add vectors? Suppose we have a vector A, and a vector usually is represented by an arrow and denoted by either a capital letter or 2 letters with an arrow on the top or other ways. And let's say we have this vector, vector A, and we have another vector, vector B, and we want to graphically add these 2 vectors. So what method is used? So the method used here is called the head to tail method, which is from the head of the initial vector, which is vector A, and that's the head or tip, to the tail of the second vector, which is vector B, and that's the tail of vector B. And therefore, adding these 2 head to tail or graphically adding these two head to tail will show this figure. And when adding two vectors head to tail, their resultant should be added as well. And the resultant will be added from the tail of the initial vector, which is vector A, to the head of the final or second vector in this case. And I'm going to call this vector C. And vector C is the resultant of vector A plus vector B. So vector A plus vector B equal to vector C. Now that's also this method which added head to tail with two vectors and their resultant is also called the triangle rule. And so since it shows two vectors added with their resultant, and they are added head to tail, and their resultant is also added, and they form a triangle. Now, the resultant is independent from the order of when adding vectors. For example, two vectors, and you want to add their resultant. The resultant is also independent from the order of which the vectors are added. So if we have vector B plus vector A is equal to C, and to graph this, so vector B will be the first and vector A will be the second, or vector B would be the initial and vector A would be the final. And as you can see, when adding their resultant, it's independent from the order of which the vector added had to take. And therefore, if and I'm gonna add to this figure, I'm gonna add also, I'm gonna form a parallelogram which combining this figure with this figure. So vector B could be here or could be, and vector A could be here. And as you can see, the resultant is independent, and therefore that's called the parallelogram rule. And so that's a summary of vector addition and the method used, which is head to tail, and including the triangle rule and the parallelogram rule. Now let's say we want to use this concept, the vector addition concept, in particular the triangle rule, to solve a problem application. Suppose that a traveler is driving on a road trip, and let's say this traveler stopped at a rest area at point A. That's the rest area. And let's say during this trip there was obstacles such as weather condition. So the weather is not good, and which caused a no service or no signals on, like, on the phone. So no phone service. And the third obstacle would be like the fuel is low. So fuel low equal to 32 miles. So that's how much fuel left. And so this traveler stopped at this rest area, and because of these issues, and when he stopped at the rest area, he also got some information at the rest area. Let's say there are 3 signs, and I'm gonna call these information as knowns. And so the first known, I guess, would be like a sign stating that to the nearest gas station there are 35 miles. And let's say that another sign stating that there are 2 roads to reach this gas station. So 2 roads. The first road is northeast, and it's 20 miles. And the second road is north. And let's say also there are construction on that area, road constructions, and new pavement. So that's another thing that this traveler noticed, and so that's the information he has, and he wants to figure out at the rest area, figure out how to, since he doesn't have any service on his phone and the weather condition, and he only have 32 miles. Let's say this traveler wants to figure out the solution for this problem. And so let's say that let's say he also looked, and he has like an emergency kit, and he looked into that, which he found an old paper map, and a protractor. And then he tried to find like a ruler, but he didn't have a ruler like to measure, but he found a protractor. And so that's all what he have available. And the obstacles are, the weather condition, no phone service, fuel low. But, on his phone he can still use his calculator. So he stopped at the rest area to use his math skills to figure out the best way to reach the gas station. With the available tools he has and the knowns. And so in order to solve this problem, the first step is to, let's say this traveler, first step he did was to draw a diagram that show the possible routes that his vehicle will be displaced to be able to select the best option. And in order to do that, he used the vector addition concept. And let's say that that he indicated the first where he at the rest area as the first point from where the vehicle at. And since he knows from based on the knowns, the first road is northeast and it's 20 mile and it's directing northeast. And so, but he doesn't know the angle, so he used his old paper map and he compared that road, and he used the protractor, and he was able to determine the angle of this road. And so he selected a point, another point at point B, which is the end of this road, and after measuring the angle that he determined is 5-degree angle. And so you draw that, and that's a 5-degree angle after using the old map and the protractor. So that's a 20 mile. Now he tried to figure out the second road on that old paper map, but he doesn't find that road. So that road is not shown, and because at the beginning he noticed there is road construction and new designs and new pavement, he assumed that this road is not shown on this. It's a new road, so that's why it's not shown on the old paper map that he has. So anyway, he added this second road, which is the direction of this road is north, and so it's a straight road, and it does intersect with the first road because both roads leads to the nearest gas station. So adding that second road, which is head to tail, so from the head of the initial vector, which is vector AB, to the tail of the second vector, which is the second road, and I'm gonna call the end of the second road point C, and that's where the gas station at. And so that's the two roads where they intersect. Again, because the second road is not shown on the old paper map, he is not able to determine the angle between between the two roads, which is this one. But since the first road is still shown on the old paper map, he was able to measure this angle, and therefore at least he has one angle that he knows. And so from this diagram, he added two vectors, and that's the possible routes that the vehicle will be displaced, represented by vectors. And when adding two vectors, again, as I mentioned earlier, or as I explained earlier, that adding two vectors will require to add their resultant, which is from the tail of the initial vector to the head of the final vector. Or actually, let me do it in a different color. So that's the resultant of uh, the two vectors added head to tail. Vector AB plus vector BC. And so, and this, and when comparing this to where we are, this resultant, there is no road here. It's not paved. It's a rough road, but the type of vehicle he's driving is able to drive on those type of roads. And so that's what he has. So he draw the diagram, and that's the diagram that looks like a triangle. These are the possible routes that the vehicle may be displaced to reach the gas station. And now, now looking at the first two routes, that's not a good option, because taking these two routes is not enough, since the first road is 20 miles and there is a sign saying that it's 35 miles to the nearest gas station. And therefore, he indicated that the second vector from B to C is 15 miles, since from the rest area to the gas station is 35 miles, and there are two roads that leads to the gas station, and therefore one of the road is given, it's shown as 20 miles, therefore the second one is 15 miles. And therefore, based on the diagram, taking these two roads is not a good option, since he only have 32 miles in his tank, like fuel. Now the second option he has is taking that rough road, which is not paved, but his vehicle is able to drive on those roads. So taking that rough roads may be a good option, but he doesn't know the magnitude of this vector. And the magnitude of AC, or vector AC, which is written this way, is unknown. And now the question is written. And so what the question would be is the magnitude of vector AC less or equal to 32 miles. So after adding these vectors and creating this diagram, the question, and seeing what's the best option, the question was, written, because, he wants to know if this second route is less or equal to 32 miles, and to see if that's a good option. And therefore, to solve this problem, now he has a diagram, and he can proceed to solve this problem, or to answer this question. And in order to solve this problem, there are other mathematical concepts that should be used, such as geometry and trigonometry. So to use a different page, and draw this again. So that's the diagram. These are that's the first vector, that's the second vector, and that's their resultant. And that's the angle that need to be found. And this one was found from the protractor as a 5-degree angle. But again, this second road is not shown on the old paper map, so he cannot use the protractor to find this angle, as I mentioned earlier, since that second road from B to C is a new road. It's newly designed, so, and it's not shown. So therefore, he at least got one angle, and in order to find this angle, geometry is used here. So drawing or extending a dashed line from the point of intersection where the first vector and the second vector intersect at this point, point B, drawing a parallel line to this line will make vector AB a transversal line crossing two parallel lines, and therefore these two angles are equal. So this angle is also 5-degree angle. And at the same time, that dashed extended line from point B is also perpendicular to the vector BC, since vector BC, which is the second road, is north, and it's a straight road. And therefore this angle is 90-degree angle. So that's 90. So the other one is 5-degree, and this is 90. And now we have the whole angle, which is 90 plus 5 equal to 95-degree. So we use geometry here, and now we can proceed to use trigonometry to, in particular, the law of cosines, to figure out the magnitude of AC, which is we're trying to find. And the law of cosine state that, let's say I want to recall or rename each side to fit the formula of the law of the cosine, or the law of cosine, and I'm going to call each side, let me clear this. So I'm going to call vector AC as side A, and vector AB as side B, and vector BC as side C. And the law of cosine states that A squared is equal to B squared plus C squared minus 2BC times the cosine of A, which is this angle. And we already found this angle. And therefore, and we know that AB, or side B, is 20 miles. And we also know that BC, vector BC, or the magnitude of vector BC, or side C in this case, is 15 miles. So that's 20 miles, the other one is 15 miles. But we don't know, we need to find the magnitude of AC, or side A. And plug in these numbers into this formula, we have B squared, which is 20 squared, plus 15 square minus 2 times 20 times 15 times the cosine of 95 degree. And to continue on this side here, a square is equal to, so 20 square is 400, and 15 square is 225, then minus 2 times 20 times 15 is 300, times the cosine of 95 degree. And so 400 plus 225 is 625, minus 2 times 300 is 600, and the cosine of 95 degree is negative 0.087. Now suppose that he used this traveler used his phone calculator to figure out these numbers, like the cosine, or but again he didn't, he can use the phone calculator, but he doesn't have any service, so as I mentioned earlier at the beginning of this problem. And now, so we have 625 minus times minus is a plus, and 600 times 0.087 is 52.2, and that's equal to 677.2. And therefore this is, a square, and we need to find side A. So A is equal to the square root of 677.2, and that's equal to 26.02 miles. And therefore side A, which is the magnitude of vector AC, so the magnitude of vector AC is equal to A equal to 26.02 miles. And therefore, to answer the question, the answer is yes. Taking this road is a convenient way to reach the gas station. And so that's the final answer for this problem. And hopefully you like this session. If you do, please subscribe for additional videos. And until then, thank you for watching.